Good evening all, and welcome to tonight's TI Technology webinar hosted by Texas Instruments Australia. We are really excited to bring you Exam Readiness Mathematical Methods for Victoria with Frank Moyer and Stephen Crouch. My name is John Bowman and I'm your host for this event. I teach mathematics to years 7 to 12 students at O'Loughlin Catholic College in Darwin, where I use TI technology to help students make stronger connections in their understanding of mathematics. And I'm very excited to introduce our first panelist for this evening, Mr. Frank Moyer. Good evening, Frank.
Good evening.
Frank has a vast experience in teaching mathematics, curriculum development, and sharing his knowledge at national and international conferences. Frank is also passionate about rich TAS and the use of CAS to strengthen and deepen students' and teachers' understanding of various mathematical concepts. So thank you, Frank, for joining us.
Pleasure.
Our second panelist this evening is Mr. Stephen Crouch. Good evening, Stephen.
Good evening, John. Good evening, Frank. Good evening, everyone.
Very polite. I like it. What a lovely start to our evening. Stephen not only is a polite and professional teacher, but he's also a talented and passionate mathematician. I know he relishes the challenge of teaching specialist mathematics to senior students, always striving to support every student to understand various challenging concepts. His teaching is supported by his in-depth understanding of the course and his use of the TI-Nspire technology. So, Stephen, thank you very much for joining us.
You're most welcome.
I was reflecting on our night ahead in the webinar and thinking how lucky all our students are. You know, you've got two talented teachers like yourselves using technology, but also we've got lots of people tuned in tonight, whether it's live or on demand, actually to also because they care a lot about their students. So I think it's absolutely fantastic. So thank you very much for joining us. Without any further ado, what you've actually come to or tuned in to listen to this evening is not me, but Mr. Crouch and Frank. So I'll pass you over to Stephen, and I look forward to learning some new things and new tricks from you, Stephen, that also will help Victorian students in their mathematical methods exam. You can see your screen. It's all over to you, my friend.
Excellent. Can you all see my screen properly?
Certainly can.
Awesome. All right. So thank you, everyone, again, for tuning in tonight. Frank and I have got some really cool stuff to show you, and hopefully you can go back to your classes and show this with your students and get some good ideas. So just as a quick sort of overview of what I'm going to be doing, I'm first of all going to look at handheld setup. So every method student needs to have the handheld set up a particular way in order that takes care of the majority of scenarios that we're going to look at in the exams. Also, I'm going to talk about the difference between problems and pages, and then how we can define variables and keep consistent when we are within the same problem in our handhelds. And then I'm going to go and look at a few useful commands, such as these four here: solve, zeros, sum, domain, tangent line, and normal line. Then going to finally go to some notes pages, show you how you can make a notes page and put formulas in there and dynamically update it as question changes. And finally, I'm going to go through, if there's enough time, I'm going to go through a couple of sample questions showing how the CAS can be used as efficiently as possible to maximize the marks your students get using the least amount of time. So without further ado, I'm going to get started on setting up the handheld. So the first thing that when students turn the handhelds on, to get them set up for the exams, you want to be going to the settings menu. So what I did to get to the screen was I pressed the on button. So on the handheld, you can press the on button, and this is the screen that you see. Now, normally what students do is they go down to the bottom here, and they just add calculator, and then suddenly on the top of here, you'll see, you know, multiple different things, 1.1, 1.3. Sometimes I've seen a handheld with 1.21 on it. So, of course, some students aren't being very careful in deleting pages when they require, etc. But before we get to that, I want to talk about the settings menu. So you can either press the button 5, or you can just use the arrows to get to settings. So either one should work. I'm going to press 5 and end up with settings. So the first setting that we need to be aware of is when we go to document settings. So when you go to document settings, this is what I tell my students to be in. In terms of display digits, it doesn't really matter. Most people, I think, are in either float 4 or float 6. personally, I like to stay on float over there. So what that means is that the calculator gives as many decimal places as it can display on questions that have long decimals that keep on going forever. For angles, I definitely recommend keep it in radian because there's more scenarios where radians are used compared to degrees. And also, calculus also only works when you're in radians mode. So if you want to differentiate sine of pi x on 6, you want your calculator to be in radian mode rather than degree mode. So that's the first thing you really want to get your students to change. Of course, if there's questions that have degrees in it, there's ways to still use degrees while in radian mode, which I'll quickly explain soon. The next one is real or complex. Now, normally, sometimes some questions do require real, and sometimes they require rectangular. It usually happens when there's questions regarding square roots involved in it and looking at domains and that sort of thing. But I prefer to have my my calculator in rectangular mode, so sometimes there's no errors that pop out. As well, there's also functions such as x to the power of 2/3 and those sort of functions that sometimes the calculator sometimes mistakes the square roots and so on of negative numbers and might throw out results that may not show on graphs. So if that does happen, then you can switch over to real. So I'm going to keep it in rectangular for now. But here is really the main one, and that is exact. Now, the biggest mistake that a lot of mathematics students do is they keep that in auto mode. Now, auto mode in some cases is all right to use, but as a method student, there really is no excuse not to be on exact mode. And the reason behind it is quite simple. When you're in auto mode, what the calculator does is it gives results that are the same type as the question. So for example, if you create a fraction and put a decimal as the numerator or denominator, the calculator will default to outputting answers in decimals as well. Whereas if you are in exact mode, regardless of whether your calculator is, whether you put decimals or whole numbers in your calculation, the calculator will always give back exact forms such as fractions or square roots, etc., etc. So that's really the main setup that needs to happen. So number one is radian, and number two is exact. Now, another big mistake that students tend to make is once they make these changes, they go and press the OK button. That is the wrong thing to do, because what the OK button does is it saves these settings only for the current problem. Whereas what you want to do is make it default. So when you go to make default, what it does is it applies these settings to the current open document, and then it saves it as the default for all new documents. So what that means is every time I create a new document, for example, there you go, that's a new document, then my my angle mode will be in radians, and the calculation mode will be in exact. So that's the first thing to take care of, radians and exact, obviously. Now, once that is done, if your students do want to do a quick calculation in degrees, for example, what they can do is, for example, if they want the sine of 30 degrees. Of course, if you type in sine 30, the calculator assumes that that 30 is in radians, and it doesn't, and it just gives back sine of 30. But we all know that sine of 30 degrees is in fact a half. So what you can do is you can go back to trig, press sine, and then type 30. And the quickest way really to get to degrees, the degree symbol, is press pi over here, press down, and then you get the degree symbol. And then what happens is temporarily for that entry, the calculator switches to degrees mode, calculates that, but still keeps the overall mode in radians. Of course, another big question that sometimes gets asked is, what happens if you want to go the other way? What if you want the inverse sine of half, for example? So if you want the inverse sine of something like half, you can press inverse sine of half, and if you go enter, you of course get pi on 6. But that's an easy enough example where we know what the answer is, pi on 6 or 30 degrees. But what if you did want the answer as 30 degrees? The best thing to do is, again, go to inverse sine, go to half, close your bracket, and then at the end, what you can do is you can press the catalog, which is the book, and then you can either go to DD or DMS. So DD, so DMS gives you the answer in degrees, minutes, and seconds. And what DD does is it gives you the answer in decimal degrees. So if I hit that, it actually gives me decimal degrees, that's 30 degrees. If I go and change the answer, the question to something a bit more sinister, I guess, for example, inverse sine of 1/3, then I'll show you the difference between DD and DMS. So DD will give us something like this. It gives us a degree, a decimal version of the degree. Whereas if you go inverse sine of 1/3 again, and you write that as DMS, so to get to DMS, just keep pressing down. Of course, also as you notice, what happens is when I press the catalog, the last used result is where the cursor snaps to. So if you use the result over and over again, you don't need to keep finding it because the calculator does that for you. Now here we go. As you can see, because my calculator is in exact mode, it's gone and given this whole big exact value that's going on. What I needed to do for that is actually press Control and Enter. So you can see that little squiggly approximate sign at the top there. Control and Enter gets you to approximate values. So of course there you go, there's inverse sine of 1/3 in degrees, minutes, and seconds. So that pretty much concludes the setup that we needed to do. That's really all there is to it. Now you can of course do it from the home menu like that, or you can use your trackpad to scroll to the top over there where the gear cog is. Click that, and then you can go to document settings as well. So you can go to document settings and you get the same results. Sometimes you might also want to go to handheld settings. So for example, sometimes what happens is students have the power standby on 1 minute. So if they leave the calculator without pressing a button for a minute, then what happens is it turns the screen off. So to avoid something like that, I like to leave it either on 3 or 5 minutes. It doesn't really matter. But anything that's not 1 minute, well, not 1 minute, would be a good idea. Hibernate, there's no need to worry about that. Of course, you must teach your students basic calculator etiquette, I guess you could say, which is Control on to turn it off at the end of the usage session of your calculator. And then, of course, Hibernate, that's not really needed. Pointer speed should be pretty much at normal. Auto dim, that's not really an issue. I think 90 seconds is a good enough number to keep it on. But the main thing is just keep the power standby at anything that's more than a minute, and then it should be fine for the big extended response exam questions. Okay, so that is the setup taken care of. I'm not sure what's happened over here. I'll just see if I can fix that. Not sure. Okay, the next thing I wanted to go through is creating problems. So what happens is over here, I've got a single page. 1.1 means problem 1, page 1. Now, if I go and I define a variable here, so one of the easy ways to define a variable is f bracket x. So let's say f of x is a function. You press Control and the template button. So control the template button, and let's say our function is fx equals x squared. When I hit Enter, what the calculator now does is it saved x squared into the function variable f. So if you do want to make sure that it's done it properly, you can actually go back and press the var button, and then you'll actually see f over there, and it says f bracket x. So you know that it is a function, and if you click on that, you actually get f bracket, and it's expecting a number. So for example, if I type in f of 6, hit Enter, and I get 36. So that's what's going on there. Now, if I wanted to graph that, a really good thing to do is press Control I. You can either press Control I, or another way to do it is press Control and Dock. So Control I or Control Dock will add a new page. So when you get to a new page, you can of course add graphs, calculator, data and stats, notes pages, etc., etc. Now the thing is, if that function that we defined over there was a big tedious function to write out, it's not a good idea to type that out again. Why do all that work when you've already got it defined in the calculator? So when you're at this stage, you can just press var, press f, x, and there you go, it graphs it for you. So that variable f continues, it continues its definition really when you go from 1.1 to 1.2. And then if you want, you can even create another calculator page. So I'm going to press Control Dock this time. I can go to another calculator page, And then we can do things like find integrals. So another little tip over here for these things is to get an integral. A really good way to do it is shift and plus. So let's say I want the integral between 0 and 2 of the parabola. Again, rather than typing x squared, I can go to the variable and either go f or f1. It doesn't really matter. Press x, and then press tab again, go to x, and job's done. So that's these tabs here are all 3 pages of the same problem. So this is problem 1, and this is page 1, page 2, and page 3. Now, if you go to a new question and you want to still save your old information, there's no point closing it and saving it, etc. The best way to do it is just go to doc, and then 4 for insert, and then 1 for problem. What that does, let's say I add a calculator. Now you can look at the top and it says 2.1 there. So I've gone from 1.3 to 2.1. Now the biggest advantage of doing this is that if I now press my var button, you notice how f of x is not there. So I've still have my handheld on. I've still got the variable saved in here. So if I press go here, var, there it is, f and f1 are saved. But in 2.1, it's not there anymore. So I'm now free to define fx as something else. So for example, let's say we're now on question 2 of the extended response section of exam 2, and the question gives us f of x. You can still do the same thing. Let's say f of x this time is a cubic. Let's say x cubed minus x squared. Enter, and there we go. Now if I type in f and then x, it'll give me back the expression which represents f of x. So that is the difference between problems and pages, and it's a really good way to separate the working that your students do, and also on the handheld, you can make sure that everything is separate that way. Otherwise, you don't want to be deleting and redefining f of x. It wastes too much time, and there's too much potential for errors to occur. So that's the difference between problems and pages. So what I'm going to quickly go through now is a few useful commands that are either accessible from menu or catalog that go through some really common exam 2 multiple choice style questions that either you or your students might not know of just yet. So the first one is solve and zeros. So here we go. So here's the list of things. As you can see, I've got one problem here, another problem here, another problem. So I've got a bunch of pages within each problem. So I'm keeping everything separate, and your students' handhelds could be set up like this as well. So the first one, like I said, is 2.1. By the way, to switch easily between pages, you can press Control left, Control right like that. Or if you want a quick overview of the entire document, you can press Control and then up. So going back to solve zeros and sum. So these are very, very common questions I've noticed in previous exams, and here's what it looks like. It says, find the sum of the solutions to the equation root 3 sine 2x equals negative 3 cos 2x for the stated domain of x element of 0, 2 pi. Now, of course, one way to do that is to just do a basic solve. So, of course, we could just do menu 3, 1, and then get root 3, and then go sine of 2x, close bracket, equals negative 3 cos of 2x, close bracket, comma x. Now here's the thing, for trig questions like this, a lot of students then go and press enter at the moment. You must make it aware to them that when you press enter, you'll get the general solution rather than the specific solutions in that particular domain. So to get the domain there, you just have to press Control and equal, and then a little palette comes up. Just press left to go to the given command, press that, and then we can put in the domain using the same palette as we did before, like this, and then you get 2, press pi, and you get pi. Hit enter. As you can see, there are 4 solutions over there. Now, the thing is with 4 solutions like this, and you look at the question, it said find the sum of the solutions. Now, to get solutions like this, what you then have to do to get the sum is you'd have to go press up, and then press right, and control that, and copy and paste it. As you can see, it's quite a lot of work just for a simple multiple choice question. What's a really easy way to actually get a question like this done is, in fact, to use what's called the zeros command. And to get the zeros command, we can go to Menu, Algebra, and 0. So instead of going menu 3, 1, this time go menu 3, 4. And this way the zeros command works is you take the equation that you've been given and take everything to the left-hand side or right-hand side, whichever your preference is, so that the other side is 0. So for example here, I can take the neg3 cos 2x to the left-hand side. So I'm just going to quickly copy this to save the typing. And then I'm going to put a plus 3 cos 2x. And then I'm going to put comma x. And I'm going to give it the same domain as we had before. And what you'll notice is that the result, there we go, the result that we get is now given as a list rather than just one thing after the other. Now the beauty of giving an answer, the answers like a list like this, is that we can do really cool things with it. For example, over here we wanted the sum of them. Well, to get the sum, you can actually just type in SUM. And as you can see, it's gone from italics to upright, which means it's a defined command. You can open the bracket, press up, press enter, enter, and what the calculator has done is it's gone and added all 4 solutions there. Now this is a simple example where we only had 4 solutions. What if we had a bigger example, such as this one, and I'd raise the domain all the way to 10 pi, and then suddenly, what's going on there? Yeah, if I change the okay, that's much better. Sorry about that. Yeah, with something like this, if you take the domain all the way to 6 pi, now this domain is 3 times as large as the original domain I had before. So here, as you can see, there's a lot of solutions here, and it's easy to actually lose track of where all these solutions are. So again, if you do the zeros command, like I did here, I'll just change that to 6 pi. It's much easier to see all the solutions, but even better is when you do sum, you get a much better answer, and you actually get the answer very quickly. Another common question that you get with these type of questions is how many solutions are there? Find the amount of solutions. So to get the amount, you simply have to type in COUNT, count. Of course, you can either type it in or just go to the catalog and it'll all be there. So whichever your preference is, you can do that. Press count and you go up again to the list. Press enter, enter, and there it tells you that there are 12 solutions in to that equation in that domain. So that's how you use the zeros command in conjunction with the count or sum command to do those sort of questions. Another very common sort of question is find the maximal domain of a function like this. Now, of course, these sort of questions can be done by hand, but the CX-CAS is very good at finding maximal domains of any types of functions. So I'll quickly show you how to get this one done. You need to define the function first, or just type it in as it is. So to get to domain, you can press the book, of course, and then you can keep scrolling until you find the function domain. Just quickly looking back at the thing, it was 2 over root 3 minus x plus 1. So in the domain command, you can just press your fraction, 2 over square root 3 minus x minus 1, and please don't forget to put comma x at the end. And what it does is it gives you the domain, which is from -infinity to 3. Of course, if you want to write that out, you can then use the notation, the interval notation, which would be -infinity, comma 3 when you write that out. Of course, the calculator won't accept that because it uses the inequality notation. But when you're writing it out, of course, you use the appropriate notation for your question. So the domain command is really good for finding the domain of these graphs. Now, for some of you might be asking about range. Unfortunately, to get the range, there's no range command on the calculator. To get the range, the best way to do it would be to simply just sketch the graph. So you take the graph, you put it on a graphs page over the specified domain, either maximal domain or a restricted one, and look at the range from there, and you can write that on your exam paper. Okay, so that on your exam paper. Okay, so here's another one, which is another very useful command. This is using the tangent line and normal line. So the first, here is our function, f of x equals x minus x log e of x. Oh, that was a mouthful, wasn't it? So the first one is find the equation of the tangent to the graph of y equals fx at the point where x equals e. So to do a question like this, I need to first make something very clear, and this is what all students need to be made aware of as well. The commands that I'm about to show you, which are called tangent line and normal line, those output what we call expressions. So they give you what's on the right-hand side of y equals. When we ask these questions, note specifically how I said, find the equation of the tangent. So what this means is that if the tangent line and normal line commands are outputting expressions, we need to convert them into equations by putting y equals in front. So what I'm saying over here is you start by saying y equals, then you use the tangent line or normal line command as appropriate, and that will get you the answer. So looking at this one here, find the equation of the tangent to the graph of y equals fx at the point where x equals e. Now, given the fact that I'm going to use this twice, I'm actually going to define this function. So x minus x log ex. So I'm going to go f of x and define it as x minus x multiplied by, be careful with this, you must put a multiply there, otherwise the calculator will bunch the x and the ln together, and that will get a bit troublesome. Now, of course, when I wrote this out, I said log e of x, as that's the notation used in examination papers, but a very good shortcut on the handheld is just press Control and e to the x, and you get ln. Of course, we all know that ln x is the same as log e of x. So I've defined it like that way. And what the question we want is the equation of the tangent to the graph of fx at the point where x equals e. So going back over there, I'm going to start off by going y equals, and I'm going to use the tangent line command. To get the tangent line command, it's menu, 4 for calculus, and then 9 for tangent line. So given the fact I've already defined it there, I'm going to press bar, press enter on F, close brackets, and comma. Yeah, now I can either just type in E as it is, or I can type in X equals E. Now, don't make the mistake of typing in this E over here. The calculator will just take that E as a pronumeral E rather than Euler's number, which is E over there. So you can just press the pi button to get the bold E, hit enter, and you actually get Y equals E minus X. If you forget to put Y equals, you just get E minus X, and a lot of students would write E minus X as the answer, and they would lose the mark for the question because that's not an equation, that's an expression. So the next question is, find the equation of the line that is perpendicular to the tangent to the graph of y equals fx at the point where x equals e. Now you might be wondering, why haven't I just said, find the equation of the normal? Well, the equation and concept and word normal is not in the study design anymore. So in order to talk about the normal, we have to actually use the words equation of the line that is perpendicular. So going back over here, again, I'm going to do the same thing, y equals, but this time I'm going to use the normal command. So menu, 4 for calculus, and A for normal line. So var f of x, comma, but this time I'm just going to write E rather than write x equals E. And what's going on? Sorry, I have to put comma x, comma E. That's much better. There you go. So there's two ways to do it, as you can see. You can either write comma x equals a specific x value, or put function, comma variable, comma x value. And I'm getting the normal line for that particular question. So there we go. Those are a collection of a few useful commands. Now, I'll just quickly introduce another couple of ones before I hand over to Frank. Let's go to a new problem for this. Here's something that a lot of students may not realize. A shortcut for doing derivatives is shift and minus. So most students probably go to differentiate by going menu and then calculus and then derivative to get that. But they can also just do shift minus, which gets them derivative. And like I said before, to get integrals, we can go shift plus as well. So rather than going through all the menus, these are really quick ways to access those particular commands. Now that I've done that, I'll quickly go through what a notes page looks like. So here's a brand new calculator screen. If you add a notes page to it, it almost looks like a calculator screen, but you can actually type in things without getting them as confused with variables or anything like that. The beauty about a notes page is you can insert math boxes. So for example, I can press Control M and then say A equals, let's say 5, and then I can say B equals 7. And then what I can do over here is I can do things like integrals such as shift plus, put A on the bottom, B on the top, put a function like this, x squared dx. And what it does is it calculates, sorry, I should have defined it, that's much better. Yep. So when you do these, you define A using the control template to get A defined as 5 and B defined as 7. And then I have this integral over here. Now the beauty about this integral is I can go back to that A and change to something like 2 and change the B to something like 10, for example. And when I update those values, what happens is this integral at the bottom, because it's got the A and the B in it, what it does is it automatically, dynamically updates this answer. So you can actually use this to create notes pages for things like the average value or the gradient or any of those formulas that require a few inputs, and then the output is a single formula. You can also make it more complicated as well, but this is a really simple idea of how to get that done. So just in case you missed it, to get a maths box, you can press Control and M, either on the computer or on the handheld. And what happens is you get this red outline box, and then you can start typing maths into it. If that outline box isn't there, then everything is just text. This is an integral. There we go. So that is how to use a notes page, or a very quick idea on how to do it, as I don't want to eat too much into Frank's time. So I think I'll stop it over there. Hopefully you've got some good ideas from here that you haven't seen before. You can go and send this to your students, and hopefully this will improve their performance in the exam at the end of the year. Okay, back over to you, Frank.
Fantastic, Stephen. Thank you for that. And as Frank opens up his screen, a couple of points that made me think as well is obviously teachers. It's good for teachers just to be reminded of a few of these things. I'm sure there's always a few bits and bobs that they may not have known about. But also students can watch these on-demand webinars as well. And that's a nice little piece of homework just for them to just go, oh yeah, that's good for you reminders for myself. So it doesn't have to be in that classroom context. So I think that's fantastic. And the second thing that was meant these was that you could set up some of these pages, couldn't you, before the exam, and save them, then use them in the exam, depending on the style of the question, and just replace the numbers, like you were just showing with the notes page.
That's correct. Yes.
Yeah. So thanks for that, Stephen. And Frank, we can see tip, math, action. Over to you.
Thank you, John, and good evening, everyone. I'm going to start off with maths actions, which really complements what Stephen has been talking about. I use it all the time, and it's something that students have said saves them time, and it also reduces syntax and going through menus. So I'll illustrate how it works with this example. So I've got a function, f of x is 2x plus 1x squared minus 1. So I want to use maths actions to find the roots and to find the coordinates of the turning point. Now, I've already defined the function in a maths box, as Stephen was illustrating. Now, if I now type in my f of x and I get the context menu, which is control menu, then you'll see that number 3 is maths actions. So it gives you the option of trying to factor, expand, find roots of a polynomial, or find zeros. So it's another way, without going to the menu, of obtaining those commands. So I'm now in a calculator page, so I'll select f of x. As soon as I have f of x, if I go to that command and control menu, the context menu, maths actions, I can find the roots of the polynomial. And it gives me the choice of either real or complex. Obviously, for methods, it's real, and it even puts in the variable. So, bingo, it's done it without me having to go to the menu or put in any syntax. All right, now I'm going to now find the derivative of that. So if Shift minus is the shortcut, X, tab, f of X. Now, there is no maths actions as yet because I haven't executed that command, but if I now go to the answer without doing anything else, control menu, I've got maths actions again, and I can do these things. Now, you notice how adaptive this is. Now, complete the square is an option now that I have a quadratic. What I want to do is find the zeros. I want to find the x-intercepts of the derivative, and I have it in that form as a list. So now, if I just have f of, this is what Stephen was illustrating earlier about using the advantage of zeros over solve in some instances, is that I now have my x and y intercepts for the turning points. Now, what about if I have an equation instead of an expression? So what if I had the derivative equal to 0? Now, without executing that, if I now go to that command and control menu, I've got maths actions. I now have solve and solve numerically as options. So that's a quick way of getting the solve command and doing it without syntax. So that's something that students have said that they sometimes find useful. Right, the other thing I want to have a look at is the piecewise template and the default else command. So I've got this function, so I've got x is a random variable with that PDF. Now, how do I get the piecewise command or hybrid function command? Well, if I go to the template button, sorry, not command, template, I've got these two here. This one here with 2 pieces, this one where I can have any number of pieces, but in fact with either of them you can have any number of pieces. So I'll select the one with 2 pieces. If you decide on I want to edit the function, you can just hit the insert. Now the insert is bottom right hand of the keyboard. You can add as many as you like. If you want to delete some of the pieces, you just press the delete button. Now, the great thing about the default else command, let's suppose I have A for, say, x greater than 5, and B. Now, if I leave the other piece of the domain empty and I just execute that, I get the complement. So, in other words, the elsewhere. So, elsewhere, x must be less than or equal to 5. So, that can be handy, not just in PDFs, but in fact in any situation where we want the complement of a domain. So, I've defined this PDF here where I don't know the value of k, and I'm going to find the value of k. Okay, I'll just copy that. By the way, to copy, if students want to select to copy on the handheld, they can hold down the Shift key and then the right or left arrow button. Okay, so Control C to copy it, and I'll add that to a notes page. Now, note that I left this part of the domain empty, the elsewhere, but as soon as I paste that into the notes page, it actually says else. And if I now recall that definition, it doesn't show it as else, it actually says what the else is, x less than 2 or x greater than 6. Okay, so we can now solve for k if I find the integral in order to find k. So remember, it was Shift plus gives me the integral. Now, I can use negative infinity to positive infinity because I've included the 0 elsewhere. So from negative infinity, which is on the pi, I'll tab across to infinity of f of x and equals 1. And of course, if I go back up to the answer, once again, if I hit the control menu, get the context menu, you've got maths actions, and it gives you the option to solve. That was just to remind you about maths actions. And so we've got k equals -5 on 256. So I'm going to copy that and redefine that function. All right, because I'm going to use this definition now to set up a notes page to make PDF problems easier. So what I'm going to have a look at is set up a page, a notes page, where I can change the function, the definition of the function. I can find probabilities, mean, and so on. Okay, so I've already partially set this up, so I'm going to define the function in here. Now, when I change the function, I can just go to this notes page, edit the function, and the rest will work. Now, even though for probability I can use negative infinity to positive infinity, in fact, when you're trying to do something like find the mean, where it's x times f of x, the calculator comes unstuck. It'll say undefined. So we really do need to include the low end, which is 2, and the high end, which is 6. In other words, the domain over which the probability is non-zero. And to check that you haven't made an input error, why not check whether the derivative, whether the integral actually equals 1. Okay. And something's gone wrong in that one because I should be getting that. I know what I've done wrong. That should be an X. Oh, okay, so it means I've obviously inputted something incorrectly. Okay, so the probability, I can put in probabilities here. Oops, I cannot do that. Try 2 to 4. 4. And so on. So I'm filling those out, but this one's not going to work because I've obviously inputted something incorrectly. And as always happens when you're live, something goes wrong. That's why I prepared one earlier. Okay, so I've set up the notes page. I've got my function. My low value is 2. My high value is 6. And this time, of course, I see that it says true. Where I'd inputted something incorrectly earlier, I obviously did something wrong. It wasn't saying true. And therefore, that's a way of students checking when they're editing the function that, in fact, everything's working as it should. Okay, so I want the probability. In this case, A is 3 to 5. So I've got the probability here. Now, The other command that students should be aware of is the round command. Often questions will say round it to 4 decimal places, and it's amazing how many students round to 4 decimal places incorrectly. So if they use the round command, which they can get from the catalogue, so you press catalogue, then S, probably the letter S, and then move up to round, and the syntax is the expression, comma, the number of decimal places. Okay, so for mean, I've inputted the formula, stored that as mu, and once again, I can round to the number of decimal places. If I wanted to round to 3 decimal places, I just edit that to 3, and so on. Likewise, variance. Now, that's the formula on the formula sheet. There is, of course, the alternative formula, which is the x squared times f of x, find that integral, minus the mu squared. Either formula should give the same answer. And once again, you can use the round command. And median, I need to solve for m, going from negative infinity to m, or from m to infinity to equal a half. Now, the advantage of having a template like this is that if I now change the definition of the function, so I'll just copy this and paste it up the top. And it's done. Except that, of course, this time you'll notice that, is it a PDF? False. So obviously that tells me that if I get either false or any input other than true, I know that there's a problem. Now the problem is that, of course, I now have to change the high end. The high end is now 44 on 7. And hopefully it now says true. So this file will be available after the webinar, so you're welcome to get students to make something similar up themselves or to use this one as is, and they can instantly get the or anything that they might want. If you want to change these probabilities, you can edit them here. Alternatively, I've also set it up so that I've got a graph and I can change the A and B dynamically, and we can see the area as a measure of the probability. Okay, so that's a notes page. Yep.
Somebody asked on that notes page, it looked like you had an image put on there as well. They just wanted to check that that was possible for you to do.
Yeah, all of those images, all I've done is using the software. It can either be the teacher software or the student software. You just get any sort of image, control copy, and then control paste, as you would into a Word document or whatever.
Fantastic. And the other, I was looking back. We think that with the that problem with that page was there was an extra variable in the integral. But like you said, once you got that template set up and you can take that into the exam, it'd always be working fine, wouldn't it?
Yeah. In fact, I was actually pleased that I mucked it up because it meant that it didn't say true over here. So yeah. At least I've set up this notes page so that it's self-checking. It would be extremely unlikely that I'd made any sort of mistake and it would still be a PDF. Chances are it wouldn't be a PDF. Yeah. So yeah, that's right.
And what's lovely is that that's available for people to get after tonight's webinar and also on the on-demand page as well.
Yeah, absolutely.
Great. Thanks,
okay.
Frank.
Pleasure. Okay. Now, another tip is the fraction tool. Now, in the 2016 exam, there was a question which asked for an algebraic fraction to be expressed in the form a plus b over some denominator. And it was, as far as I was concerned, it was a gift question, but according to the examination report, 42% of students scored 0. So obviously students are unfamiliar with some appropriate commands, and other students did get the answer, but they did something like polynomial division, which, you know, for a 1-mark question or whatever it was worth, just seems over the top. So one of the commands that students can use for that sort of question is they go to the algebra, and there's number 9, fraction tools, and proper fraction. So a proper fraction of that expression, and bingo, there it is. Except, of course, that's not the required answer because, of course, it said a plus b over the denominator. So, in fact, students would have to give in order to get full marks, I'd imagine they would need to express the answer in that form, even though the calculator thinks that the other one is the better way of expressing it. The other way you can do exactly the same thing is just the expand command. So menu, algebra, expand, and select that expression, and it does the same thing. So that's just another little tip. Okay, now want to have a look at a problem involving the sampling distribution. Now, this is similar to a question. It's different. It's not the same question, but it's the same sort of question as was in the Northern Hemisphere paper, which was administered in June 2018. Now, teachers may not be aware that the VCAA also has a Northern Hemisphere timetable. So there is an exam, a June exam, available on a different part of the website. And if you can't write down my web address, it doesn't matter, just Google it. And that's an exam that students can do as a practice, which they are unlikely to have seen before. And anyway, the question is something like this. Random samples of 100 jelly beans are taken from a large jar. Assume that the jar contains 10,000 jelly beans and that the standard deviation of the sampling distribution of red jelly beans is 0.04. If less than half of the jelly beans are red, how many jelly beans are in the jar? Now, in previous years, what the examination papers tended to do was to define the random variable capital P hat and then talk about perhaps the standard deviation of capital P hat. The problem with that is that students could then go to a formula and without understanding what was going on, still get an answer. So at least they needed to know that what this was talking about, that the sampling distribution is the distribution of the random variable capital P hat. And the formula is fairly straightforward. Okay, so they need to find P, the true population proportion of red jelly beans, given that standard deviation. So we've got the square root of P times 1 minus P. I think the samples were 100 from memory. Yep. And my memory serves it correctly. I think it's 0.04. And once again, just to remind you, if you just now do control menu, you've got maths actions, I can solve. And notice that this time the variable is P, so it's rather neat. So P is either 0.2 or 0.8. Because it's got to be less than half a red, so therefore it's got to be 0.2 times 10,000 or 2,000. Times 10,000 or 2,000. All right. Confidence intervals. So this sort of problem, In one random sample of 60 jelly beans taken from the jar, the proportion of black jelly beans is 0.15. Determine an approximate 95% confidence interval correct to 4 decimal places for the proportion of black jelly beans in the jar. All right, so what we're given is that n is 60, lowercase p hat is 0.15, and students should know the relationship between the number of successes and the p hat. The other bit of information students should know is that for a 95% confidence interval, the value of z is 1.96. For a 90% confidence interval, it's 1.64. Now, this is the formula that's given on the formula sheet. Now, when a question similar to this was asked on the Northern Hemisphere paper, it was worth 2 marks. So students can't expect to get full marks by giving just the answer. They would need to show some sort of working, so perhaps show what they would substitute into the formula. Nevertheless, TInspire will give them the answer. So they don't actually have to type all that out. So to work out a confidence interval, it's menu and it's statistics and confidence intervals, which is number 6. Now the one you want is number 5. So you've got a single proportion and you're using, it's a Z interval. You know, the T distribution is not examinable, obviously. Now, this time we're given the number, I think the sample size was 60 this time. Now, the number of successes, now we were given a proportion. The proportion was 0.15. So if I multiply that by 60, that'll give me the actual number. And I can change the level if I need to. And there's the value. That's the lower value, and that's the upper value. And my time's up, so thank you very much for listening, and I hope that there is something useful in the presentation.
Thanks for that, Frank. Just before you sign off, somebody did ask that the CAS gives exact solutions. Can you use exact solutions rather than using the 1.96 as a multiplier?
The study design specifically says 1.96.
Yeah.
So, I mean, that's the reason why I would use 1.96.
Yeah, I think that most exam boards do the same, I think, if I remember rightly.
Yeah. It actually is specifically in the study design if you look at one of the dot points.
Yeah. Fantastic. So thanks very much for that, and I have appreciated not only what you've shared, but also the questions that have come in from people. Hopefully we've answered your questions for you. If you do have any other questions that you want to ask the gentleman, then please do so, just as we begin wrapping things up. So thank you, Frank.
Pleasure.
So, as I said, please do send any of those questions through. Not only do we use those questions to help us tonight, but we can use those in a post in the feedback afterwards, and we can use those to actually help guide future webinars so that we actually cater for you, because obviously we put these webinars on for teachers to not only make their teaching better, but also students' learning of mathematics more enriched. So please fill these feedback forms in as detailed as you can. Your following on from tonight, your certificate attendance will be emailed to you in the next 48 hours, along with a link to the on-demand and YouTube versions of the recordings, as well as those relevant documents that Frank and Stephen mentioned and showed tonight. After we leave tonight, if you do have any post-webinar follow-up, please feel free to phone or email us. I know that we'd love to hear from you. And that brings us, sadly, to the end of tonight's webinar. Frank and Stephen have both shared 3 webinars recently, all on topics to do with the Victorian exam boards. So thank you, gentlemen, for sharing that with us and your expertise on these subjects. So thank you.
Thank you all for listening.
Thank you.
And equally, thank you very much for the attendees for joining us this evening, or if you're watching it on demand. We do put these on for you, like I said already, so I hope you found it beneficial. Thank you very much, and have a great night, and enjoy the rest of this term. Thank you very much, and all the best. Bye now.